Hi folks. Today we're doing a little investigation into polynomials and their behavior. Now, I think the best thing to do with this polynomial investigation, which you can find in the video description below, would be to take a look at it or possibly print it out, and then go to Desmos and graph each of these functions. You could draw just a rough sketch here on each of these grids and maybe notice a few things about these graphs. I think it's going to be more useful for you to discover the properties than for me to just tell you. That said, if you don't want to do that, then I can walk you through those graphs fairly quickly here. So it says, use technology to graph the following and copy down a rough sketch. So last call here for you to go and do it yourself, which again, I think will result in deeper understanding. All right, let's head to Desmos. So here's the first graph that is on that sheet. Okay. And the things that we're going to have to catalog, if we go a little further down this investigation, is how many turning points a cubic polynomial may have. So these are all cubics. You notice they all have x cubed in them. How many turning points and how many x-intercepts. So if I'm just cataloging that as I go here, this first one has one x-intercept and it has no turning points. It does have sort of a hesitation or a saddle, or what we should call a point of inflection on it, but it never actually turns around. So it's possible for it to have 0 turning points and 1 x-intercept. Let's put that in there. A cubic may have 0 turning points, and it may have 1 x-intercept. All right. Let's try the next one. This one has a turning point right around, let's see if I can get it to show up, right around here, and also a turning point here. So it's got 2 turning points. It also has 2 x-intercepts. So it could have 2 turning points. All right, I wonder if it could have more turning points. Let's check out some other cubics. So here's another cubic. This one only has 1 x-intercept again, and it has 2 turning points. So we saw that before. I wonder what's going to happen in this last one. Oh, that doesn't even look like the other shapes. Okay, so it's got 3 x-intercepts and 2 turning points. Let's see, so it could have 3 x-intercepts. Now let's go and graph them all together. It's a big garbled mess. Okay, that was a mistake. Let's see, this first one, if I read it from left to right, it goes from up to down in the end. The next one, it goes from down to up, if I read it from left to right. It's got some turning stuff in the middle, but as far as its end behavior, down to up. The next one goes from down to up, and the last one also from down to up. And you'll notice that in the last 3 of these cubics, it started with a positive. So all the ones that start with a positive ended up moving up as we go to the far right, whereas the one with a negative ended up moving down as we go to the far right. All right, so that gets us through kind of the investigations of these ones. I'm not going to sketch them because I just put them up on Desmos. Graph the following. Ooh, the next ones all have powers of 4. So we call that a quartic. Now the thing we're going to be asked to talk about for these ones is also the number of turning points and the number of x-intercepts. We also might want to catalog the basic shapes. Okay, so let me get rid of my cubics. Here's my first quartic. Oh, it just kind of looks like a parabola, hey? But it's a little fatter on the bottom, or a little more, I guess, a little more horizontal at its vertex. So this is one that has 1 turning point and 1 x-intercept. Let's catalog that. It could have 1 turning point, and it could have 1 x-intercept. Okay. Next one. Now this one has 3 turning points. It's got a turning point right here, and right here, and right here. That's so nice on Desmos, hey? They just pop up for us. And it has 2 x-intercepts. So 3 turning points and 2 x-intercepts. So this could have 1 or 3 turning points. It looks like there's no more room there. Okay. In terms of general shape, the purple one went from up to up. Okay, so it looks kind of like a parabola facing up. The black one goes from down to down, if we read from left to right. So from the bottom to the bottom, I guess. is the best way to say it. So it's almost like a parabola facing down, but it does have some turning points in the middle. Let's check out some other ones. Next one. This one was kind of like the first one we saw, except it has two x-intercepts. So let's check that out. Oh, we already had two x-intercepts. And it has one turning point. Let's check out another one. This one had, anything weird happening later on? No, just that basic shape. But it has no x-intercepts. Ooh, let's check that out. So it could have 0 x-intercepts. Maybe I should just reorder these. Okay, so I'll erase them. 0, 1, 2. You can probably guess what's going to come in. But let's check out what happens when we actually see the graphs. So this one goes from up to up. Okay. Next one also goes from up to up in terms of its far left and far right behavior. And let's see. It's got 3 x-intercepts, and it's got 3 turning points. So it could have 3 x-intercepts. You can probably guess what's coming next. No, that's weird. There we go. We get to see it. It goes from down to down. And again, notice it has a negative first term. So this one has 4 x-intercepts. And it looks like kind of a morphed M shape. We could have 4 x-intercepts. Now, given that all these quartic functions either go from up, stuff happens in the middle, to up, or down, stuff happens in the middle, to down, the number of turning points has to be odd. The only way you can go from up to up is to have maybe 1 turning point, or 1, 2, 3 turning points, or 1, 2, 3, 4, whatever, going to be an odd number to get you back up there. All right, last little bit for us to check out. So right up until here, all these graphs are magic. And here's the thing about this chapter. By the end of it, they're all not going to be magic. We're going to find ways that we can graph them, that we can find their axis intercepts easily. We'll have a hard time finding their maximum and minimum, meaning their turning points, but that's going to be the job of calculus next semester, or one of the jobs of calculus. Here we go. Here's the next one we're supposed to graph. X squared minus 2x. I mean, I don't think we're surprised that that's a parabola. And then I'm going to graph x by x minus 2. Hold on, where'd it go? Ooh, they're the same graph. Okay, let's try the next couple. So we've got this one. I don't really know what's happening. There we go. That's a cubic, and it went from down to up, if we kind of follow it from left to right. Okay, let me graph this next one. Oh, these are the same. Oh my gosh. Okay, the next pair. You know what's coming. Here's number 15, and here's the very last one. They're the same. Now, let's go back to numbers 11 and 12 over here. This one and this one. And maybe I'll go back to my regular settings. This one in black is actually an easier form to graph from. When I turn it into x by x minus 2, what I have it in is factored form. You factored out the x as compared to what it looks like in purple here, or the equation from the purple graph. Once you have it in factored form, you know the x-intercepts. That's the good thing about a factored form. So when I look at x by x minus 2, the numbers that zero out that expression, x by x minus 2, are either a 0 out front or a 2. A 2 would make the whole bracket into a 0. That's why we have x-intercepts at 0 and at 2. So let's check it out for the next one. Let's forget about the expanded form in number 13. It's really not that helpful. But if I look at number 14, what I would guess from that factored form is that it will have x-intercepts at -1, because -1 zeroes out the first bracket, at 2, because 2 zeroes out the second bracket, and at -4, because -4 zeroes out the last bracket. And we're talking about number 14 here. Let's see if that's true. Okay. oh my gosh, it really does have an x-intercept at -4, so that's from the last bracket, at -1, that's from the first bracket, and at +2. If you knew the shape, you knew sort of the down to up behavior, and you knew the x-intercepts, then you could probably generate that graph. Okay, so if I were to actually head in here and try and do this one by hand, I'd know it has these x-intercepts. And I know it's a cubic. It's got a positive number to start with from its kind of expanded form here. So in the end, it's going to go up. So its basic shape is going to be something like that. So I can just try and sketch that graph out. More or less like that. I could find the y-intercept easily by subbing 0 for x. Wonder, is that the actual shape? Let's go back. It really is, eh? I've just changed the axis scale a little bit. Now it looks a little bit more like what I drew. But we found the x-intercepts, and once we know the x-intercept and the shape, we can get a good idea of what the graph looks like. So let's take a look at the very last one. We've got 16 has these properties. It's got an x-intercept at -1, an x-intercept at -3, and an x-intercept at 2. We know that because -1, 0 is at the first bracket, -3, 0 is at the middle bracket, and 2, 0 is at the last bracket. When I graph it, yeah, it really does have those properties. It has x-intercepts at -1, -3, and +2. The only weird one is this x-intercept here. You get a bounce. Like it touches the x-axis, but it also has a turning point there. It bounces off the axis. And the reason for that is because that x+1 term is all squared. So you get this kind of parabolic shape there. All right, so given that 15 and 16 mean the same thing, we can get a lot of information from the form in number 16. I mean, we know it's going to be an x to the 4 graph. We know it's negative out front, so it's going to go from down to down. And we know where the x-intercepts are. It's pretty useful. On the other hand, number 15, which is the exact same graph, is pretty difficult for us to graph. So let's go to the last bit of this. So all of these ones that we see on the right-hand side are going to be just the ones on the left-hand side, but they're factored out. Okay, so let's say, whoa, questions B, D, and F are in factored form. The nice thing about that form is that I can easily tell the x-intercepts. Hey, Mr. Toms, can we learn how to put polynomials in that form? Because obviously this form here on the left is way better than the form that's on the right. Okay, so if we can get it in that form, which will be a big part of the business of Chapter 3, then we can easily graph these. Just a couple of things to mention. From the cubics, what we learn is that if you have an odd top degree, or degree of the function, we call the highest power on x the degree. If the degree is odd, let's just make a little space for ourselves here. If you have an odd degree, then there are two choices for the function. It's either going to look like it comes from down below and does some stuff in the middle, and then it moves upward. I don't know how many turning points it has. Depends on whether it's a degree of 3, 5, 7, 9, or whatever. But it's definitely going to go from down to up, or from up to stuff happens in the middle to down. All odd degree functions will look like that. Even degree functions, you actually know this from parabolas. They either go from up and stuff happens in the middle and then back up. I mean, mine are kind of jagged here. A polynomial is actually going to be smooth. Or if the leading coefficient, or the first number you see, is negative, then it's going to be from down to stuff happens in the middle to down. Now, I'm not graphing these particular functions that are on this page, just giving some examples. That may seem like a lot to memorize, but we'll work on factoring these, And I'm going to show you a trick in the next video on how you can memorize those different shapes. That's as far as we're going to go today with this investigation. If you did it yourself and then came here to confirm, that is fantastic. Hopefully you got some patterns yourself. Next class, we'll look at this in greater detail and try and develop some rules. But again, for the next video that should be part of this lesson, you can get some ways of learning the different shapes fairly easily. Take care, folks.